Hello, boys and girls, and this is a new type of lesson. Right, okay, can I get you, please, to write down everything that's in the window, so example 1, and the example there, also titled as differentiation, and the subheading is the chain rule. Feel free to pause the video at any time, so you can make notes, or if you want to rewind the video, again, feel free. But this is our lessons on chapter 8. Now, the first type of differentiation that we're going to look at is the chain rule. Now, the chain was much like the differentiation that we've done in the past. So the differentiation that we've done in the past, we know is x to the power of 4. So if that's y, then dy by dx, you bring the power down to make 4x, then the power will go down by 1 to make cubed. So 4x cubed would be how you differentiated that. The chain rule is very, very similar to that. So with this one here, we've got y equals 3x to the power of 4 plus x, and that's all to the power of 5. Now we want to differentiate that. Now the chain rule, which we will come on to in a little bit more detail in the next couple of examples, is we bring the power down, so we bring this power here down to 5, so that would become 5 lots of 3x to the power of 4 plus x. Then the power drops to make the power of 4. Now it's never going to be quite that simple. So what we also need to do is multiply that by whatever's inside the brackets differentiated. So if we differentiate inside the brackets, we get 12x to the power of 3 plus 1. And then we can simplify that by multiplying what we just differentiated inside by the number outside there to get 60 x to the power of 3 plus 5 multiplied by 3x to the power of 4 plus x all to the power of 4. Alternatively, they wouldn't dock you marks if you left it as 5 lots of 12x to the power of 3 plus 1 times 3x to the power of 4 plus x to the power of 4. And they usually consider it good form if you leave the biggest power, so the original thing that you differentiated. So that's this bit here, if you have that as the last bit, usually because it's got the biggest power. So that's the first one. What we're now going to have a look at is example 2. So again, feel free to pause whenever you'd like. So here we've got y equals the square root of 5x squared plus 1. Now, in theory, this should all be in brackets. Now, as you well know, we could write that as 5x squared plus 1, then square rooted. So that's to the power of a half. So if we do exactly the same as we did last time, so that's going to be dy by dx equals a half multiplied by 5x squared plus 1. Then we need to subtract 1 from the power, so that's going to be to the power of minus 1 half. And then we multiply by whatever's inside the brackets, differentiated, so that's going to be 10x, because the 1 just goes away. And then we can actually simplify this, so the half times by 10x would leave us with 5x bracket 5x squared plus 1. All to the power of minus 1 half. But the question doesn't say that, so we've got to differentiate it. But the final part of the question, it says, find the value of dy by dx, which is our equation here, at the point 4, 9. So we then need to substitute in our x value of 4. So by doing that, we're going to have 5 lots of 4, which is 20, times by, then substitute 4, and that's going to be 16 times 5, which is 80, plus 1, which is times 81 to the power of minus 1 half. Now, going back to C1, the way we do with minus a half, would be 20 times by 1 over 81 to the power of a half, which you should know is square root. So it's going to be 20 times by 1/9, which we can leave as 20 over 9, or if we simplify that down, 20 divided by 9 is 2, with 2 remainder, so 20 and 2 ninths. Okay, so that's the majority of the chain rule actually done. There are a couple of extra bits and pieces. And another way of writing the chain rule, this is very useful when it comes to C4, but we're going to have a slight look at it now. Another way to do the chain rule is dy by dx equals dy by du times by du by dx. The reason that this works algebraically, of course, is because you could just cancel out the u's, and then it would be dy over dx. But the way we could use this in this question, it's completely up to you which method you use, is we use a substitution of x squared minus 7x, and we call this u. Sorry, that equals u. So if we do that, we've got y, sorry, we've got y equals u to the power of 4. So if we then differentiated that, we get dy by du equals 4u cubed. Now we've also got the fact that u equals x squared minus 7x. So if we then differentiate that with respect to x, so du by dx, that's a u, that would give us 2x minus 7. Now going back up to the way I explained the chain rule up there, we can then say that dy by dx equals dy by du, which we can see is this one here, multiplied by du by dx, which we've just worked out to be this one here. So by doing that, we actually get the answer of 4u cubed multiplied by 2x minus 7, which we can stick in brackets. And then all that's left is to substitute back in what that u was. And we know that u was this bit here. So 4 lots of x squared minus 7x times by 2x minus 7. Oh, damn it, Wayne. That's 4u cubed. So, sorry, that should have been the cubed there. And then if we write it around the other way, 4 lots of 2x minus 7, x squared minus 7x cubed. Now, like I say, you can do it either method. I don't particularly like this method, but I think it is useful to see where it comes from. Okay, so let's have a look at this one. So we're not ready to differentiate just yet. But if we, again, use that method that we just used, then we can say that u equals 6x minus 3. And then we've got y equals 1 over, and the square root of u, so that's u to the power of a half, or u to the power of minus 1/2 if we bring it up. So if we do dy by du, we get minus 1/2 u to the power of minus 3 over 2. And du by dx equals 6. So if we then multiply those together, dy by du times by du by dx, we get minus 1/2 u to the power of minus 3 over 2 times by 6, which gives us dy by dx equals minus 1/2 times by 6 is going to be minus 3, and then u to the minus 3 over 2. Now, it's asked us to stick in the value of x as 2. But at the moment we don't have any values of x, so we've got to put it back in terms of x. So that would be equals minus 3 lots of 6x to the power of minus 3 to the power of minus 3 over 2. So what we need to do here is we need to put this back down on the bottom. So because it's a negative fraction, negative fractional power, we can have minus 3 over 6x minus 3 to the power of 3 over 2, which of course we know is the square root, and then cube that. So we then substitute in our value of 2, so we end up with minus 3 over the square root of 6 times 2 is 12, take away 3 is 9, so it's going to be the square root of 9, and then cube it. So the square root of 9 is 3, times, or cube that, you're going to have 27, so you're going to have minus 3 over 27, which goes down to minus 1/9. Okay, finally, so you could do, if we go back through that, we can use the first way we talked about the chain rule on example 3 and example 4. It's completely up to you how you do it. Personally, I like using the first two methods. I think it's far easier. But please be aware of the example used in example 3 and example 4. Just be aware of that method because we will come back to it in C4, which isn't that far away. Right, the final one, this is a little bit different. We've got find the value of dy by dx at the point 2, 1 on the curve with equation y cubed plus y equals x. Now, dy by dx is exactly the same as 1 divided by dx by dy. So whenever we come across an equation where it's in terms of y, so we've got y cubed plus y, what we simply do is we work out dx by dy. So the way we do that is if x equals y cubed plus y, dx by dy is going to be 3y squared plus 1. So then if we go back over here, dy by dx is just 1 over dx by dy, or in easier terms just flip upside down, then dy by dx equals 1 over 3y squared plus 1. And again, just like the last question, it asks us to substitute in the values, but this time we do not substitute in the value of 2, because remember that value of 2 is an x value. What we do is we substitute in that value of 1. So dy by dx will equal 1 over 3 lots of 1 squared plus 1, which is going to be 1 over 4. Okay, what I would like you to do for next lesson is to watch this video, obviously, which you've now already done, but also have a go at this question here. And this is in your book, it's exercise 8a. That's on page 135 in the new books. I'm not sure what it is in the old books. And the question is to differentiate 4 lots of 2 plus 8x to the power of 4. And that's your question for when you get in next lesson.